In this video, I'm going to show you how to use U-substitution in special cases where you're integrating an indefinite integral, and when you equal your whatever to u, nothing starts to cancel out. Like nothing's helping, nothing's happening, no movement. So these are going to be called special cases. That's what I'm going to call them. And I'm going to jump right into these, and you'll see exactly what I'm saying right now. Okay, so we're looking at this given integral, okay? Something inside of something, that's what we're going to let u equal. In this case, it's going to be x minus 2. Now, if we were to find the derivative of that, we would get 1. Is 1 going to cancel anything? No, it's not. It's not going to cancel jack crap. So it is freaking useless, okay? And this is what I mean. Nothing's canceling out, so you have to get creative. And these are the special case problems. So what do we mean by get creative? Well, here we're going to solve for x. Then we get x equals u plus 2. Now we must rewrite the entire integral in terms of u. So now dx equals du. And our integral gets rewritten as the following. 4 times, again, we let, oopsies, wrong thing. We let x equal u plus 2. So u plus 2 goes in here. Then we have the square root of what? Well, we let u equal x plus 2. So u goes in here. Then we have du. Beautiful. I'm going to now distribute and condense this and simplify it, right? So we get 4 times u is 4u. 4 times 2 is 8. Then again, this is being multiplied, so we also have to distribute that u. I'm going to rewrite it as u to the 1/2. Then I'm going to distribute it. So 4u times u to the 1/2 gives us what? 4u to the 3/2. Why? Because this u is raised to the power of 1. When you're multiplying two variables, you add the exponents. And when we add these exponents, 1 plus 1/2, what we're going to have to do is we're going to have to make it so that they have the same denominator. When we do that, we get what? 3/2. Okay, just thought I'd show you that just in case anyone's lost. Then this guy is super straightforward. And that is our rewritten integral. Now, everything is in proper form, everything's been simplified, and we can find the antiderivative. Okay. We get 4 to the u plus 1, 3/2, plus 1, plus 1, plus 1, plus c. Okay. Now, let's simplify this a little bit. Okay, again, 3/2 plus 1 is 3/2 plus 2/2, which is going to give us 5/2, right? So here we have 4u to the power of 5/2 over 5/2. Oh my gosh, Siri, please stop. 8u, and then 1/2 plus 1 is just 3/2 over 3/2 plus c. Now we need to get rid of those fractions in the denominator because that is illegal to leave like that, okay? Now, can you guess how we're going to get rid of it? Well, reciprocal. Always reciprocal. What you do to the bottom, you got to do to the top. This cancels it out entirely. That's the whole principle, right? Okay. What do we get here? Now we have 2/5 times 4u to the 5/2 plus 2/3 times 8u to the 3/2. Okay. Now let's multiply. We get 8/5u to the 5/2 plus 16/3u to the 3/2 plus c. Oh my god, how dare I? Plus c, plus c, plus c, plus c. Okay, so that is it for this one. That's literally it. Really not that bad. This guy looks, oh, it looks awful, but it really isn't bad either. Okay, so before I'm doing anything, I'm going to just look at it and see if I can simplify it. Okay, feel free to pause the video and try it out. Simplify it before you let u equal anything. Okay, that's all I'm going to say. So, what the heck do we do here? Well, I'm noticing that this guy can be factored, I guess, right? Because x plus 1 times x plus 1 gives you x squared plus 2x plus 1. All right? And then we have all this to the power of 2. But this can be rewritten as something differently. This can be written as x plus 1 over x plus 1 with the multiplicity of 2 raised to the second power, right? Because this guy never disappears. And when you have an exponent raised to another exponent, what do? You do it. Right? So that is even oh my gosh, English is so hard today. That gets simplified to x plus 1 to the 4th power. Okay, now she's simplified. Now we can use U-substitution. Again, it has to be inside of something. The only thing that's inside is that x plus 1. And if we were to do it like normal, we would get nowhere. So this is a special case problem, right? What we're going to do, solve for x. We get x equals u minus 1. We let dx equal to u, right? And we're going to rewrite the entire integral in terms of u. So our integral, I'm going to erase this so I have more room. So now our integral is going to get rewritten as x must now be u plus 1. So where we have x, I'm going to put a parenthesis, and then I'm going to fill it in, right? It gets filled in with this, u minus 1, over. Then again, parentheses, we let u equal x plus 1. So x plus 1 gets written here to the 4th power. Oops, I forgot dx. And here would be du, right? Okay, we can simplify this numerator, so I'm going to simplify it. We just get u over, oh my gosh, hello? Okay, better. We get u over u to the 4th du, and then this can be simplified even further, right? Because we have a multiplicity of 1, and then we have a multiplicity of 4. So we subtract those, and we get what? 1 over u to the 3rd power du, but this is not in proper form for integration, so we have to bring it to the numerator. So our integral is going to be rather u to the negative 3rd power du. Now we can find the antiderivative, whatever. So we have u to the negative 3rd power plus 1 over negative 3 plus 1 plus c. That's going to give us what? U to the negative 2 over negative 2 plus c. Now we are going to bring this guy to the denominator because that's where it belongs. Then we have negative 1 over 2u to the 2nd power plus c. And are we done? No, because we have to substitute what we put for u. So I'm going to clear some of this stuff so that I have more room. All right, when we plug in u, we get our final answer. We get negative 1 over 2 times x plus 1 squared plus c as our final answer. This guy, feel free to try it. I don't think this one's too crazy either. Yeah, okay, let's jump into it. U, it's going to be x plus 3, because that's the only thing inside of something, right? Again, if we were to find the derivative the normal way, we'd get nowhere. So we have to be creative. We're going to solve for x. X equals what? U minus 3. Rewrite the whole integral in terms of u, right? Already messing up. Beautiful. Nothing like it. Okay. We said x equals u minus 3, so u minus 3 goes in here. Then we've said u equals x plus 3, so we must replace x plus 3 with u dx. Oh wait, du. Oh my gosh. Hello? All right. Now we are going to simplify this. Let's simplify that numerator. 5 minus 3 is 2, so we get u plus 2 over u to the 1/2 du. Then we can simplify even further by breaking it up. So we have u over u to the 1/2 plus 2 over u to the 1/2 du. This can be simplified, right? And when it's simplified, because this is to the first power, so we could just subtract it. And when we subtract it, we get u to the 1/2 plus 2 to the u to the negative 1/2, because this has to be brought to the top, right? Du. Now we can find our antiderivative. Everything's pretty perfect. There's nothing else to really do to it, right? So let's keep going. U to the 1/2 plus 1 over 1/2 plus 1 plus 2 u to the negative 1/2 plus 1 over negative 1/2 plus 1 plus c. We get what? U to the 3 over 2 over 3 over 2 plus 2u to the 1/2 over 1/2 plus c. When you use the reciprocal, you get 2 over 3 u to the 3/2 plus 4u to the 1/2 plus c. But is it done? No, it's not. Why would it be done, right? We have to plug in u. Cut. Cut. Cut it. Cut it. Cut it. Okay. All right. Now let's plug in u. And she's done. That's it. Nothing too bananas. Not bad. Okay. Okay, just had the urge to crack everything. I apologize. Okay. Now try this one. I really think that this one won't be bad to try on your own. It's literally just what we've been doing over and over again. Okay. Let's do it. U equals x plus 1. We're going to have to solve x equals u minus 1, right? Now, we're going to rewrite the whole thing. We let x equal u to the u minus 1 over u squared du. We can rewrite this as u over u squared minus 1 over u squared du. Then we can simplify it. We get 1 over u minus 1 over u squared du. But we need that denominator to be in the numerator so that we can touch it. So actually, that's going to be u to the negative 2. All right, now we can find the antiderivative. And we get what? When you see this, I hope you know what it is immediately. Natural log. Okay, ln. Now, minus u to the negative 2 plus 1 over negative 2 plus 1 plus c. Running out of room. We get what? ln of u minus u to the negative 1 over negative 1 plus c. Going to rewrite it so it's not disgusting. We have two negatives here, so that's going to cancel out, and now it's going to be positive. Then we're going to bring this guy to the denominator. Okay, and it's almost done. We just need to replace u. And that is our final answer. Not bad. Not bad at all. All right, this is our last one. Again, pause the video. This is actually going to be pretty similar like the last one. Pretty freaking similar. So try it out. Hello? Okay. Now we're going to simplify this. Going to simplify even further. Now we're going to find the antiderivative. We have a negative. Got to bring it to the front. We're going to bring this to the bottom. So we get 3 in the numerator and we get u in the denominator plus c. Then we're going to plug in u. Okay, yeah. And that's our final answer. Okay, brain's like low functioning today. A lot of little teeny tiny mistakes, but whatever. I hope you enjoyed this video. In the next video, we're going to go over definite integration. So if that's something that interests you, stay tuned for that. Thank you so much for watching. Bye.